Have a happy learning to you all. Today we are going to explore how CRC works and why it is essential in digital communication networks. If would you like to dive deeper into modern digital communications, kindly watch this video. Myself, G.H. Ram Ganesh, completed BTech IT and ME Computer Science Engineering, working as an assistant professor in the Department of Information Technology in Kamaraj College of Engineering and Technology. After seeing this video, you can get the following outcomes. First one is what is CRC and the introduction to CRC and how CRC works and the CRC polynomials and the error detection and the error correction mechanisms and the efficiency and the performance of the CRC and real world applications of CRC and tips for how to implement a CRC. Then first, introduction to CRC. In the real world, the data is transmitted through the medium in various channels. In the time, we need to check whether our data is secure or not. So that cyclic redundancy check is one of the most commonly used error detection mechanism which is used in digital networks and storage systems, which is used to ensure data integrity. Then it is based on polynomial division, where the data is treated as polynomial division as well as divided by a predefined CRC polynomials. Here the original messages will treat as dividend and the divisor will treat as generator of X. In a computer network, data can be corrupted due to the following things. First one is noise, interference and transmission issues. So that we need to save our data, so that CRC helps to ensure that the transmitted data is correct and has not been altered and corrupted. From this diagram, we can easily understand how CRC works. Here CRC is very efficient to find errors. That error may be single bit error and burst error. Single bit error, in a segment of line, one bit may be altered or corrupted. That kind of bit is called as single bit error. Suppose a burst error, the entire segment of data may be corrupted or may be altered during the transmission use or any noise and interference. So that we need to recover our data and we need to send us original data in intact, so that we need to use here CRC problems. Then that CRC is transmitted, which is appended and calculated into the original message, as well as in receiver side the same data is verified whether the sender information and receiver information CRC is same, then only the data remains intact original. Then values does not match, the message is rejected. CRC polynomials, in sender level and destination level, they can give as a data in a polynomial. We can see this polynomial equation here, x power 6 plus x power 5 plus x power 4 plus x squared plus x, for example. Okay, here we can extract the coefficient of x values. Suppose if you see in this problem, the polynomial equation has x power 6 has coefficient is 1, x power 5 coefficient is 1. So that here I am writing like that. Here x power 4 is 1, here x power cube is not found. So that here 0 is present. Yes. Then generator polynomial, which is otherwise denoted as divisor. The same process is followed here also, that polynomial presentations is converted into the binary polynomials. Then CRC generation at center side. First, find the length of the divisor value, that will be denoted as n. Then append n minus 1 values into the m of x. Then perform the binary division operations. Then remainder of the division is called, finally answer is a cyclic redundancy check code. Before we are going to perform a binary division operation, we must be knowing about the XOR operation, exclusive OR operations. We must be remind this truth table. Here A is a variable and B is a variable. Suppose if they are giving same kind of inputs, it will produce 0 output. Suppose different inputs means it will produce 1 as a output in exclusive OR operations. You may wondering, we are going to do binary division operation, but why it is essential to know about exclusive OR operation? In following example, you may realize that why it is more essential to learn about exclusive OR operations. Let me see an example sum. Here they have given us to find 4-bit CRC for the data 1100, 1010, 1110, 110 using x power 4 plus x power cube plus 1. This is the m of x. This polynomial is generator of x. That is the original message. We need to transmit that original message from sender to receiver. Then I have denoted this original message as in the name of m of x. Then generator polynomial x power 4 plus x cube plus 1. Here we need to extract the coefficient of x values. 1 into x power 4 plus 1 into x cube. Here x squared is not available, so that here I am writing 0 into x squared plus x also is not available, so that 0 into x plus 1 into x power 0, anything power 0 is 1. So that here I am writing likewise x power 0, 1 into x power 0. So that here we can retrieve and extract the binary values of from these polynomial equations 1, 1, 0, 0, 1. So that I have extract these coefficient as a binary values from these polynomial equations. So that here I have 5 bits. So that here I am writing n equal to 5 bits. Then we need to calculate n minus 1 value, then 4 bits. In divisor we have we need to calculate n minus 1 4 bits value. So that we need to append in least significant side 4 consecutive zeros in original message. Here we are going to perform a binary division operations. The divisor which is placed to be here, it is a g of x. This is m of x which is placed as a dividend. Every time if we are going to do a binary division operation, 2 answers will be get. First one is quotient and second one is remainder. We won't bother about quotient value, but we need to consider remainder value. That remainder value is denoted as cyclic redundancy check or checksum value. This is our answer. So that here we are going to see about how we are going to solve this problem. First, this is our m of x. We need to add 4 consecutive zeros into the m of x. Then this is my divisor value. How many times 11001 may divide this content? 1 time. So that I have written this 1 here and 11001. Now I am going to do a exclusive OR operation. In binary division problem, we need to remember that exclusive OR operation. Here same input means my output is 0. Same input is output is 0. So that here every time I am getting 0. Then it from front value of 0 is placed no role in that front side. so that we ignore these zeros. Then in binary division, in next element we need to bring from there to here, but in that divisor we are having 5 bits, so that we need to bring 5 numbers from there to here, 0 1 0 1 1. Then how many times 1 1 0 0 1 can divide this element? One time, so that here I am writing 1 1 0 0 1. So same input, my output is 0, different input, my output is 1, same input 0, same input 0, different input 1. Then we need to bring this 0 to be there to here, we need 5 elements, so that I need to bring this 0 to here, so that the same process is repeatedly done, which is divide by 1 1 0 0 1, so that different inputs we can get a answer is 1, so that the same operations will repeatedly. Here 1 1 is 0, here also 0, in front 0 which plays no role in that operation, so that we can ignore that 0. So I am going to divide this element by 1 1 0 0 1. One time we can divide, so that 1 1 0 0 1, here I have written this, then 0 1 1, different inputs, my output is 1, different input, my output is 1, different input is output is 1, same input means my output is 0, so that here 2 zeros are comes. We need to ignore these zeros also, which has no role in that place. Then we will get that answer is 1 0 1 0. This is our reminder. If you append 4 consecutive zeros as a dummy CRC code, you will get a original CRC value as 1 0 1 0. Now we can append these 4 bits into the original message. Here I have attached these 4 bits into the original message. This is this is our given original message. We have added this new CRC code. Then advantages of CRC, which is more reliable and very efficient to find error correction and single bit errors and burst bit errors. Then which make a low computational cost. Then which is very flexible to generate various length of the data and it generates different polynomials. Then real time applications of CRC, which is mainly used in different kinds of networking protocols such like TCP, IP, transmission control protocol and internet protocol, and DHCP, dynamic host configuration protocols. Then which is mainly used in Ethernet, Wi-Fi and other protocols also. Then these CRC problems and mechanisms used in storage devices for error detection in hard drives and memory side. Then communications, which ensures data integrity in communication systems. In summary, cyclic redundancy check is mostly used error detection mechanism which is very flexible and very efficient to utilize and to ensure the data integrity between the multiple devices in digital communication systems. Thank you so much for listening. Thank you.